Hey guys, welcome back to my channel Euclid Mathematics. So today we are going to solve one of the previous year question from CSIR NET December 2017, which is a multiple answer question. So we are going to learn Lagrange's method by using one of the examples. Okay, so let's get started our question first, then I will explain how we can use Lagrange's method here. So our question is here: consider the Lagrange's equation, which is x square dz by dx plus y square dz by dy, which is equal to x plus y into z. Then we have to find out which of the general solution is correct between these four options. Okay, so here our option number first, it is given f of xy by z comma x minus y by z, which is equal to 0 for an arbitrary differential function f. Option B, it is given f of x minus y by z comma 1 by x minus 1 by, which is equal to 0 for an arbitrary differential function f. C, f of 1 by x minus 1 by y, which is equal to z for an arbitrary differentiable function f. And option D, it is here z, which is equal to xy into f of 1 by x minus 1 by y for an arbitrary differential function f. Okay, so we have to figure it out which one of the option is correct between these four options. So for solving such types of the question, for finding their general solution, we have to use Lagrange's method. Because of that, we have the equation in the form of Pp+Qq, which is equal to R. In partial differential equation, we use with respect to x differentiation as P, with respect to y differentiation as Q, with respect to double x differentiation as R, with respect to double y differentiation as T, and with respect to x and y differentiation as S. Okay, this is the general notation. It is easier to remember. Now let's get started our solution of our example by using Lagrange's method. So compare here given equation with Lagrange's equation, and Lagrange's equation, it says that Pp+Qq, which is equal to R. So we have to compare with that equation and our given example. Okay, so x square dz by dx. Okay, P is a dz by dx, Q is a dz by dy, and P, which is capital P x square, capital Q y square, and R it is remaining here. Okay, now here value for P, it comes P, which is equal to x square, Q, which is equal to y square, and R, which is equal to x plus y into z. Now we got the value for P, Q, R. Now as per the Lagrange's equation, substitute these values in the form of Lagrange's equation. Then we get it here: dx by P, dy by Q, dz by R. Okay, now here for finding the value for their constant C1 and C2, compare any two of the fractions here. So you can take it for 2 or more 3 also, and then go further finding their C1 and C2. Okay, so here, and that C1 which represent by U and C2 represent by V, and then find out their solution. Now here first value for C1 is, so here compare any two fraction between we have 3 here. Okay, so you can compare first with respect to 2, or you can add both of them and compare with third. Just make sure that we want the value for C1 and C2, okay, in order to get the solution. Okay, now let's go for comparing first two. Because of that, dx by x square, which is equal to dy by y square, which is easier to find out their solutions. Okay, so consider here dx by x square is equal to dy by y square, and then let's find out the solution. So here I consider dx by x square, which is equal to dy by y square, and integrate both of this side. Okay, so I integrate here the integration of x by x square, which is equal to integration of dy by y square. Okay, so and find out their integration. So integration of dx by x square, which is a minus 1 upon x, dy by y square, which is a minus 1 upon y, and plus constant c. Okay, so that is the value for c, we want it here. Okay, now let's take it to the other side and find out the value for c. Okay, so 1 upon x minus 1 upon y, which is equal to c1. Okay, why? You can take it that c as a minus 1, no, it's minus c1 as a c. Okay, now how I written here c, which is equal to, so take that c here, which comes minus c, and 1 upon x, it is here 1 upon x minus 1 upon y. Okay, so minus c consider as a c1. Okay, this is a constant. It doesn't matter what value it is here, negative, positive, or anything else. Okay, because this is a constant. So c minus c considered here as a c1. So 1 upon x minus 1 upon y. This is the first value for c1. Okay, now let's find out the value for c2. Consider the suitable fraction for the value of a c2. So here next the fraction dx by x plus dy by y minus dz by z, which is equal to 0. Okay, so integrate it, which 1 upon x integration, which is log x, here log y, minus 1 upon z integration log z, with respect to dz it is there. Okay, so which is equal to second constant c2. So I got the value for c1 here and a c2 here. C2 you can write by using logarithmic rule, log x plus log y, which is equal to x into y. Okay, So log x plus log y means log of x into y, and when we apply exponential to the both side, then it remain xy only, okay? And log of a minus log of b upon log a upon log b, okay? Log of a, this term, minus log b, we can write log of a upon b, okay? So xy upon z here, which is equal to c2, okay? Or you can write z upon xy, which is equal to c2 also. That means 1 upon c2 is also c2. This is the constant, okay? For our solution, we have to consider these possible cases, okay? And now let's go for the value for c1 and c2. So here c1 is here 1 upon x minus 1 upon y. I solved it further, y minus x upon xy, which is equal to c1. Now here we have to understand one thing. For finding the solution by using Lagrange's method, we have to write c1 in the form of c2 or c2 in the form of a c1, okay? So try to adjust some terms here in a c1 that we can substitute the value for c2 here, okay? So we can see here xy by z, which is equal to c2, okay? So here denominator xy is present, okay? So I feel that, so we have to divide z here and multiply z here. So I got the value for xy by z, which is equal to c2, okay? And substitute that c2 here, okay? So our next value, it comes y minus x upon z multiplied by xy by z, which is equal to c2. Substitute this value, okay, which is equal to c1. Okay, so Lagrange's method, it says that we have to find out the relation between c1 and c2, okay? So in order to find out their solutions, okay? So c1 here, I got the value for c1 and c2 in the form of their c1 and c2, okay? Now take c2, it is here, next term it's look like y minus x upon z, which is equal to c1 into c2, okay? So c1 into c2, this is a constant, okay? So we can write the constant multiplied by constant, some other constant. So write that c1 and c2, which is equal to c3, okay? So I got the third constant here, y minus x upon z, which is equal to c3, okay? So now find out the solution of our given Lagrange by using Lagrange's equations, okay? So here the solution by using c1, c2, we write here as by using Lagrange's method, f of c1, c2 0, or f of c2, c1 0, or c1 which is equal to f of c2, or c2 which is equal to f of c1, okay? Now substitute all the values for c1, c2 and c3, okay? So we get our required option from our example, okay? Now here we know that the c2 here as a z by xy, okay? And c3 here as a x minus y by z, okay? Now write f of c2, c3, which is equal to 0, okay? F of c2, c3 means f of c2 value for c2, it is here z by xy, and c3 it is here y minus x by z, which is equal to 0, okay? So I got the first value z upon xy into y minus x by z, which is equal to 0. Now let's go for the next solution. We can find multiple solution, okay, by using c2, c3, c1. Try to find their combinations, okay? So second, f of c3, c1. Why I choose that c3, c1? Because of that in our option, which is given this way, okay? So f of c3, c1 is a 0, okay? So for the next option, now here next I consider f of c3, c1, which is 0, okay? And we know that the value for c3, we got it here x minus y by z, and say c1 is 1 upon x minus 1 upon y, okay? So f of c3, c1 is a 0. Now let's go for the another possible combination. So another solution we can write it as the c2, which is equal to f of c1, okay? Now c2 we got it here z by xy, and c1 which is a f of 1 upon x minus 1 upon y, okay? So take that denominator xy to the other side, then we get z, which is equal to xy multiplied by f of 1 upon x minus 1 upon y, okay? These are the solution we got that by using Lagrange's method, okay? Now let's verify which one of the option is correct from our given options. So our option first, it says that f of xy by z, which is equal to x minus y by z, which is equal to 0, okay? So that means f of, we got the c1, c2, which is a 0. This is our required answer. We found it here before. So first option is correct, okay? Now let's go for the second. So next it is here x minus y by z into 1 upon x minus 1 upon y, which is equal to 0. Exact, that answer also we found it here, okay? That second one is also true, okay? But third one, z is not there only, okay? Z upon xy is there. So option C is wrong. And option D, it says that z upon xy, which is equal to f of 1 upon x minus 1 upon y. That option D is correct, okay? So we got the correct option A, B and D, and wrong answer is a C here, okay? This is a multiple answer question for 4.75 marks. It's a quite easy question which asks for 4.75 marks, and every year CSIR NET repeats such a type of the questions, okay? So I hope you all have understood my answer of this question. So thank you everyone. Thank you for my lecture.